Good morning, students.
Good morning, ma'am.
Have you all had your breakfast?
Yes, ma'am.
Okay. No. Why? Okay. After my class, you can go and eat. Okay. Now you see. Can you all able to see this picture?
Yes, ma'am.
What picture it is? What picture? Rocket launch. Okay. Is there any connectivity lies between our Earth and the Moon? Yes. What connection is there between? What connection is there?
Gravity force, I think so, ma'am.
Gravity. Okay, yes, very good. Clap hands for her. Now, if I throw this chalk piece, what will happen? It will fall down. Is it not? When it falls down, it is just getting attracted towards something. When I'm throwing, every object which is present around us is having some attraction. Okay. Now, so what topic we are going to deal with today? Gravitation. Can you repeat the topic?
Gravitation.
Gravitation. Yes, very good. Gravitation. Okay. Can you list out some of the activities which is happening in our daily life related to gravity? Okay, now listen. Before introducing the concept gravity, I'm just telling one story. You all know that famous scientist Sir Isaac Newton. He only the first person who discovered gravity. You all know. One day he was sitting under an apple tree. He was just thinking, and he was sitting under an apple tree. Suddenly, an apple falls on his head. At that time, he thought that how the apple is falling on my head and how it is attracting towards the earth. That idea is just changed to the gravity concept. From that only he discovered the concept of gravity. Okay, now you just see. Can you all able to see this chart? Thank you. You just consider this as an apple tree. Here the apple is falling down, but Newton is not here. You just think, okay, he is here. Apple is falling down due to gravity. Okay. Similarly, when you are pouring some water into the tumbler, means the water is falling downwards. Why the water is not moving upwards? Have you ever imagined that? Why the water is not falling upwards? Due to gravity. Okay, due to the gravity only, it is falling down in the tumbler. Similarly, the man is standing on the earth. We are all standing on the earth. If the gravity is not there, can we stand on the earth? No, we will be flying like a bird. Is it not? Okay. Now, here one boy is there. He is just putting two objects. On one hand, he is putting a ball. On another hand, he is putting a feather. Does it have the same weight, this ball and the feather? No. How you are telling it will be different? It is different, right? How? Because you are having a ball which is having a larger mass. You are having a larger mass. The mass will be more for this ball when you compare with the feather. Okay. Similarly, for every object present in the universe will be having different masses. Thank you. Thank you. Every object present in the universe will be having different masses. So, what is gravity is? You just listen. Gravity is nothing but every object present in the universe will have an attractive force. What is happening there? Attractive force. Some attractive force will be happening towards an object present around us. Okay. Now, that if an object is present means we are having. You just listen. I am having a duster here. Okay. Here the duster is here, and I place it on the table. When I am placing it on the table, the duster is having some mass, and similarly the table is having another mass. When you compare both this, the masses will be different. There will be mutual attraction taking place. When the mutual attraction taking place means you will be calling that as gravitational force. How do you call it as? Gravitation. Yes. Yes, very good. Gravitational force is nothing but mutual attraction. Gravitational force is nothing but it will be having a mutual attraction. What is mutual attraction? What? No answer is coming. What is mutual attraction? What? Yes, attraction is happening on both sides. Mutual attraction taken by the objects which is having different masses. With mass, you should remember this point. Okay. Mass is what? Yes, it is a weight of an object. Very good. Clap hands for her. Okay. Now, as I said already, if now you are having a water bottle here. You are having a water bottle. That water bottle is just placing. If a bench is not there, if you are just holding means whether it can be able to place this water bottle? No. Yes. If similarly, now I am writing on the board. When I am writing on the board, this chalk is getting attracted towards the board or not? Without attraction, can I able to write? No. Since the attraction is taking place only, I am able to write it on the board. Otherwise, you can't able to write not even a single word. Okay. Now, what is gravitational force? Yes, gravitational force is nothing but the mutual attraction taking place between the two objects which is having the certain mass. Okay. Now, another type of force we are going to see. Now, you just see what I am doing. You have to observe and tell me what I am doing. What I am having in my hand? A bangle with a thread. You just observe and tell me what I am doing. Can you all able to see what I am doing? What I am doing? Sorry. What I am doing? I am just rotating the bangle with the thread. Okay, here which is the larger object present here? Bangle is the larger object. I am not asking about the. I am a center object present here. Can you all able to see me in the center? Okay. When I am rotating like this, I am the center object which is having a larger mass. When you compare this bangle with myself, which is having larger mass, I am only having larger mass. That is what happening in our earth also. Now, if you just see, this is our earth. What is revolving around the earth? Something will be revolving around the earth. What is it? Yes, very good. Clap hands for her. That is nothing but moon. Moon will be revolving around the earth. Now, earth is a larger object present at the center. Similarly, when I'm doing like this, the moon, you consider the bangle as a moon. The moon is just revolving around the earth. I am considering her as the earth. When I'm doing like this, there is having some force. We are having some force. That is a gravitational force. But here you are having some type of gravitational force. You will be calling that as centripetal force. Yes, very good. That is the force which is acting towards the center. You will be calling it as what force? Centripetal force. That means center seeking force. How do you call that?
Center seeking force.
Yes, very good. Clap hand for yourself. Center seeking force. Can you say me some other examples for centripetal force? In real time examples, you will be seeing many things. Yes? Yes. In festival times, in November time festivals and all, people used to do like this. Yes. In Karthi festival like that, they will be telling, no? For that also, we are using that centripetal concept. Okay? So you have an idea about what is gravity, gravitational force and centripetal force. Now we will be discussing some interesting topic about the universal law of gravitation. What is that? Universal law of gravitation. What is universal? Yes, I can't hear you. Universal? That means if a concept is there, means the whole world should get accepted that. Okay, that is the universal law of gravitation. Who discovered the gravity concept? Sir Isaac Newton, yes, he was the only one who discovered this universal law of gravitation also. It is discovered by whom? Sir Isaac Newton. Have you heard anything else about Newton? Okay, now you just look at this picture. This is our Earth. You just listen. This is our Earth. Okay, and this is Moon. Which is a larger object here? Which is having a larger mass? Earth is having a larger mass, larger object as well as larger mass. Larger mass. So here when you compare the Earth with the Moon, what will you tell? This is a smaller object or larger object? This is a smaller object and smaller. What smaller? Mass. You can ask me here one question. Sorry, smaller mass. Here you can have one question. Earth is also a very big object and Moon is also a bigger object. How you are telling? How you are telling that Earth is a very bigger object when you comparing with Moon? Generally, if you see means Earth is a very bigger object. If you ignore Earth and if you are seeing means Moon is a very bigger object. When you compare both the Earth and the Moon, you are having the Earth as a bigger object and Moon is a smaller object. So now I am taking this larger mass as capital M1 since M. I am just taking it as capital M, and for Moon I am taking it as small m. This is the difference between the Earth and the Moon. I am taking the larger mass as capital M and smaller mass as smaller m. Okay, now you will be having some particular distance from the Earth to the Moon. Is it not? You will be having some particular distance will be there. So I am taking it as d. Up to this you are able to follow me? Okay. Now listen. Now since the Earth and the Moon is taking, you will be telling no. Gravitational force, I told you that mutual attraction will take place. If mutual attraction takes place means the Earth is also having some attractive power and the Moon is also will have some attracting power. You can ask me how both is getting attracted, ma'am, and how this is possible. We can have some questions, right? So what is happening there means there is happening some gravitational force concept. So I am taking that gravitational force as F. Gravitational force as F, which is directly depend on. Now the gravitational force is directly depending on what? Masses. Yes, very good. Gravitational forces. This symbol denotes the proportional sign, and this is directly proportional to the product of both masses. I am having the bigger mass and smaller mass. So I am taking that capital M and small m. Okay. I am taking this equation as 1. This equation you are able to follow me? Yes. Okay. Next, now what I am going to do, as it is mass is getting directly proportional, I have taken this. Now mass, the gravitational force is inversely proportional. Inversely proportional means N. You will be having the inversely proportional means this is silently taking place, the distance. You can't able to see it directly. So I am taking it as, I am just squaring this D. This is equation number 2. Can you all able to identify the difference between 1 and 2? This is also gravitational force and this is also gravitational force. It is directly depending and it is this is indirectly depending on. Okay, now what I am going to do is, I am just going to compare both 1 and 2. Why I am comparing this means, because both we are having gravitational force, I am just going to compare. On comparing equation is, on comparing equation 1 and 2, first we will be taking the gravitational force. Okay, now directly proportional to what I am going to compare, capital M into small m into 1 by d square. Okay, now if I multiply this means what will you get? Capital M by d square. Okay, now I want to remove this proportionality constant symbol. In order to remove that, I am just going to introducing a constant. Yes, very good. F is equal to gravitational constant. I am taking a G here. Since we are dealing with the universal law of gravitation concept, I am taking the letter G here. G and capital M, small m by d square. This will be the universal law of gravitation formula. Okay. If someone asks you to find the universal law of gravitation force means you need to remember this one. Okay. I am taking this as equation 3. Okay. The value, many scientists have decided have given the value for this G. That is G, you know that universal gravitational constant. Before that, can anyone come here? Can you find out what it is? Can you find out if M means what it will match here? Yes, mass, we just match it. We just rotate it. It is a mass of bigger object. If D means, is this correct? Okay. Okay, thank you. Clap hands for her. Now, you just see when you compare, when you are comparing the equation 1 and 2, you got the value. That is the gravitational force. Now, what we are going to do? Here we have we have got the value where F is equal to. How do you call the F? What is it? F is gravitational. What? No answer is coming. Gravitational force. And what is the capital M denoted by?
Mass of an earth.
Mass of the earth. Mass of the earth. But how do I call that? Mass of the bigger object or larger object, whatever it may be. Mass of the larger object or bigger object. And similarly, small m denotes mass of the smaller object. Mass of smaller object. What is D?
Distance between
D is the distance between the two objects, that is our earth and the moon. Distance between two objects. Okay. Now we want to find the value of G. As I told you already, from this equation, from equation 3, what I am going to do? I am just going to find out the value of G. You just take this equation. F is equal to G, capital M and small m divided by d square. Since I want to find the value of G, I am just taking the G outside. Okay, I am just taking the G and I am cross multiplying the other terms. When I am doing like this, what do you get? F into d square and divided by, yes, your numerator will come to the denominator. That is product of the bigger mass and the product of the smaller mass. If you are getting. Now, I think in your earlier classes you could have studied that what is the unit of force. SI unit of force you could have studied in your earlier class, no? Yes, very good. That is, your unit of force is nothing but Newton. Similarly, if you are finding the distance mean, how you will be taking in meters. Since you are having the square, I am just squaring the term. Do you all understand? Okay, now here I am having the bigger mass and smaller mass. What is the unit of mass? You will be measuring it in grams or kilograms. So I am taking it in kilograms. Here some people will ask one question. Here you are having a bigger mass and you are having a smaller mass. How you are putting kilogram for both? Because since mass is a universal one, we can't take the bigger as well as smaller. You just take it as a single one. So mass is a kilogram. Unit of mass is nothing but it is a kilogram. Okay. Now what will come? When you multiply the Newton into meter square, you will be getting Newton meter square and you will be getting the kilogram square. Here when the denominator term goes to the upward means you will be getting that Newton meter square kilogram per minus square, or else you can write in this way also, Newton meter square per kilogram. This is also a correct way. Okay. Okay. So the value of G What is the value of G means? Many scientists have find out the value and did many experiments. It is nothing but 6.7 into 10 power minus 11. You have to write this unit. This is very very important. Okay, that is Newton meter square per kilogram.
Square.
Oh, sorry. Okay, thank you. Okay, up to this you are able to follow. Okay, from this now you are going to tell me one question. I am going to ask you one question. For that you are going to answer me. What does that mean? Here, you just tell me. This is our Earth. As I said you already, our Earth and Moon. And similarly, I am having our solar system. What is come in between the solar system and middle? You will be having Sun. How many planets are there in our solar system? 8 or 9? 8 or 9 what? 8. What are the planets? Can you name them? Mercury, Venus, Earth, Mars. Can anyone stand up and tell me? Yes, you. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Yes. Pluto is not a planet, but it was a planet before. Okay, clap hands for her. Sit down. So, here you will be having planets. So, I am just drawing Mercury, Venus, and you will be having Earth. Here also you are having Earth, and here also you are having Earth. Okay. Now, here you are having, I am telling that Earth is having a larger mass. Earth is having a larger mass, and here Moon is also having. Similarly, which is having a larger mass here in the solar system? Sun. How we are telling the Sun is having a larger mass? Sun. You are telling Sun is a larger mass when you comparing with what? You are comparing with the planets and the other. Earth also we are having. When you compare the